Hi everyone, my name is Yuriy Prykhodko. I'm Principal Technical Account Manager in AWS, and I'm also leading a solution and project which is called Cloud Intelligence Dashboards, and I'm quite active in FinOps world, and everything related to FinOps is part of not just my day job, but also part of my passion and area of interest. Right, today I'm going to talk about FinOps for AI, and I'm going to talk about how to maximize cost efficiency of your generative AI workloads. But first of all, before we start, I'd like to just set the layout for this talk. And when we mean like AI, we usually think of three different tiers of using AI tools and applications. First tier is ready to be used applications, which kind of out of the box provides capability to boost your productivity, such as Amazon Q for Business or Amazon Quick Suite, which just recently was launched. Or tools like Amazon Q Developer, which provides you software development lifecycle, productivity, efficiency increase. Then another layer is models and tools which you can use to build your generative AI applications. And the great example here is Amazon Bedrock, because it allows you to use different variety of models. And then infrastructure layer to build and train your AI models, such as SageMaker, or just different types of specialized EC2 instances, such as AWS Trainium or different GPU instances, which we provide as well. So how usually Gen AI is priced? Yeah, so let's also think about this. There are several dimensions, and in this kind of Amazon Q and Quick Suite or application like Gen AI services, usually the pricing is per user per month. There are some, like for example, Quick Suite has also pricing for storage and for indexes, but most of the cost will go for like per user per month. There are like usually no prices for like tokens separately, but mostly user per month. Then Bedrock is priced, it's per model, per region, but the pricing is defined, again, majority of pricing is driven by tokens, so the price is usually per 1,000 tokens, the pricing unit. And for EC2 and SageMaker, usually, again, there are some exceptions, but usually in most of the cases, you will be paying for instance hour for your inference or for your training. So today, I'm going to focus on Bedrock, just because, to cover everything in 20 minutes, it's technically not feasible. And I'm going to share with you a few things which I've personally learned by working with some customers on their Gen AI applications, and basically some lessons which I learned, and the ways how you can approach tracking, monitoring, and optimizing generative AI workloads on Bedrock. You all know that token is in Gen AI, token is a basic unit of text processing and also of the billing, right? So I don't probably need to explain nowadays what token is, but it's generally a billing unit or text processing unit. What is important about tokens that since it's the main pricing unit in Bedrock, we need to understand that tokens is LLM specific, so it's very model specific. So the same input, the same text input, which you send to two different models, will provide you two different numbers of tokens, both input and output tokens as well. So it's important to understand that, like choosing model matters. Then the pricing is based on both input tokens and output tokens. So here the both parts matter. It's not like data transfer where only data transfer is free, but here input and output tokens are billed, and you are paying for them. So before we start running our workloads in Bedrock, our Gen AI workloads in Bedrock, the first few things which we need to decide is what's the right pricing option for us and what's the right model we should use. And as for the pricing options, we have three main pricing options on Bedrock. On demand, it's basically pay as you go. There are no commitments, and it's the best place to start for everyone. So if you in doubt, start with on demand. On demand pricing option is basically when you run workloads on like shared infrastructure under the hood, and you don't need to commit to any terms, but from the other side, you have some service quotas, you have some request per token limits and transaction per token request per second limit and transaction per second token per second limit, and that's something that you need to consider. If your applications need higher performance or higher rates of requests per second, tokens per second, that's where you need to think and look at provision throughput. Provision throughput is not necessarily a cost optimization constraint. It's a pricing option which allows you to provision some infrastructure for you and get better performance, lower latency in some cases. And with provision throughput, you pay not for tokens, but for model units, right? And conversion from model units to tokens, it's a bit challenging. So if you feel a need that to get to provision throughput, usually reach out to your AWS account team and they will help you to figure out the best options. But generally, don't think about provision throughput as cost optimization thing. In some cases, it could be more efficient, but in most of the cases, it's more like performance-related exercise. In provision throughput, you also need to commit for some period of time from 3 to 6 months. And then batch inference. If your GenAI applications don't need real-time inference, if you don't use real-time chats with your users, you can use batch inference to process prompts in batch, usually in background or basically in some batch jobs. And with batch inference, you can get up to 50% of price savings. So again, here are the pricing options to consider. Now, the next step which we need to choose, right? The next part which we need to select is we need to select right foundational model. And here is the different consideration dimensions which usually customers should think about. It's your prompt size and whether your prompts will fit to model context window, right? So whether your model is has context window which can fit your prompt size, what's the maximum output tokens as well, which your model can provide, then cost per token for each of the models. So cost per token is different per model, then model accuracy, if it's able to provide you the results that you want. Input and output modalities. So it's basically if you need output as a text or you need output as a generated image. So, or if your input will be just a text or your input would be a generated image. So models are different by modality as well. And you also need to consider the service quotas for each model in each regions. There is a service quotas of requests per minute, per second, and tokens per minute, which you also need to consider when you run on demand. And if you need more, you can either increase these quotas, but you also can consider provision throughput to get dedicated infrastructure. Here is a quick example why model selection matters. And we can for a use case with, for example, 20 million tokens, input tokens by using Bedrock foundational model and 1 million output tokens for text summarization use case, you can see how selecting different models by model size and capability from Amazon Nova Lite to Anthropic Claude 4.5 Sonnet, we can see how cost will be different. It's by factor of tens, so it's very, very big. And when we run traditional workloads like EC2, we already, I think, get used to the fact that we don't need to spin the largest instance type just because it's more performant. Here is the same approach. We don't need to start with the most capable and largest model, which would be the most expensive probably. We need to choose the right model, and usually better to start with the least or somewhere in the middle and then go up if results with those models are not the ones that you expect. Okay, so we selected now the model, we selected pricing option. Now we started to use Bedrock and deployed some workloads. So now let's talk about cost and usage monitoring and the tools that we have. It's very important to understand that in Bedrock, there are several nuances like how your usage is built. For example, if you use so-called first-party models, it's the models which trained and sold by Amazon and basically by us. Those models are built as billing entity AWS. Then second-party models, it's the models which developed and trained by the different model providers, not AWS, but they sold by AWS. Usually those are the open source models from different providers, the ones that we can also sell because they are open source. And they also build as billing entity AWS because we sell them. And there are third-party models. It's the models which developed, trained, and sold by the model publishers or model providers. So those models actually built as AWS marketplace billing entity. It's important to understand for several reasons, right? First is there will be a little difference in how you can visualize and how you can track the cost. For first-party and second-party models, for example, in Cost Explorer, you will see that service is a bedrock and billing entity AWS. In cost and in usage report, you will use like line item product code column to get all the bedrock cost and usage. But for third-party models, in Cost Explorer, service name would be like bedrock edition with the brackets specifying the model provider. Billing entity would be AWS marketplace, and product code in core will include just marketplace product ID, and product name will have basically a name of the service and the model provider. So this is like important thing to understand, and which makes things a little bit more challenging, right? But once you understand them and use the right tooling, it becomes not that hard. As with any workloads in the cloud, with cost monitoring, the foundation is establish cost alerts, right? And here you can use AWS budgets. And again, with generative AI workloads, it's very important to set the spending boundaries up front, right? To say, okay, how much I can allocate for this POC and how much I'm ready to spend for this POC or for this product overall. Set these boundaries as a budgets. You can use budgets per tag, per application, per account. So set those spending boundaries and make sure that you have alerts to get notified when you exceeding the budget. You can use cost anomaly detection, right? And get notifications about anomalies when some anomaly spend happened, even if it's within the boundaries, you will get notifications with cost anomaly detection. Now, that's where the interesting thing comes into play. And not many people know about this. And that's what some customers learn in a hard way. If you use cost anomaly detection and you use third-party models, so models like Anthropic Claude, and they build as AWS marketplace. So you need to know that AWS market spend is not covered, AWS marketplace spend is not covered with cost anomaly detection. So cost anomaly detection doesn't cover AWS marketplace. So if you use third-party models, think about, like, just know about this and make sure that you adapt to this, and you use things like AWS budgets to, to control it, or you use CloudWatch alerts, because in CloudWatch you can get bedrock usage, and you can set up CloudWatch alerts to get notification, or you can use, if you're using some custom cost anomaly alerting system, you can also, like run some core queries, analyze anomalies. So, but just be aware that cost anomaly detection doesn't cover AWS marketplace, and so doesn't cover third-party models. Now, let's talk about cost visibility. There are several tools which you can use. You probably know about this. In console, you can use AWS Cost Explorer. It's pretty easy to get started. You just need to know that, like, which services you need to choose for first, second, and third-party models. You can use data exports, cost and usage report, or focus data for detailed billing analysis if, like, you want to run some queries over this, or you can use ready-to-be-used dashboards, like Cloud Intelligence dashboards in Amazon Quick Suite. And there are a few things which in Cloud Intelligence dashboards you can get on top of what is, for example, not available in Cost Explorer by default. Let me cover those. And also, for those who are not familiar with Cloud Intelligence dashboards, just in few words, it's an open source solution from AWS, which you can deploy in your environments, and you will get quick suite dashboards with actionable insights, lots of recommendations for your spend and usage data. And we cover, like, very comprehensively Bedrock and SageMaker and all the AI services, cost and usage data, we provide a lot of insights. So in one of our dashboards, which is called Kudos, for example, for Bedrock, we provide ready-to-be-used visuals which already consolidate all together this marketplace and Bedrock usage. You can consolidate multi-pair data from multiple pair accounts, and you can actually, out of the box, see your Bedrock spend over different dimensions, like, for example, spend per pricing model. So you can see how, like, whether you're using anywhere provision throughput or batch inference or like on demand, or we provide also details about spend per usage type groups. So it's kind of higher level abstraction or categorization where your spend belongs to. For example, you can see in total how much your organization paying for input tokens, for image generation, for output tokens, for cache, prompt caching, for prompt optimization. So all the different Bedrock features in human understandable way, very easy to track. Then we also provide details about per model cost and usage. So you can see how much like your model per model cost differs day to day, and you can see how many tokens you consume for each of the model. And another very important part that we just recently added, ability to see cost per 1,000 tokens or cost per unit for all the models that you use. So you can see for all the models how much it costs you prompt caching, how much input tokens cost. So you can actually, track it and see, oh, like, for example, why in some accounts we are using more expensive models while we have similar use cases in which like other applications use cheaper models as well. So it's quite nice and available out of the box. All right, so now we know how to track this cost and how to set up alerts. And now we are going to cover with few examples what you can do to optimize the cost, right? So, and to optimize the cost, because the tokens is the main pricing unit. So if you use less tokens, you spend less, right? So you can optimize amount of tokens. And it includes several optimization techniques. First of all, like, make sure that your prompts are not essay, but like they are very concise, and as least text as possible. From the other side, engineer the model input and output. You can provide in the prompt how you would like to see your output, limit your output details. Sometimes models could be chatty, so provide some constraints how you would like to see outputs. You can use input pre-processing. So for example, when your users send a prompt, you can actually pre-process this prompt. You can reduce its length, remove some elements which are necessary, like new lines, double spaces, all these things which then consume tokens but don't add any value. You can add to the initial prompt some details. How would you like to constrain the output to reduce the amount of output tokens? So you can, and then send this prompt to the LLM. If your applications use things like just real-time chat with LLM, you can then reduce amount of tokens which you consume by sending chat history, right? You can use sliding window technique where instead of sending the entire chat history, you send just the last 20 messages, for example, or you can use chat summarization technique where you, again, instead of sending the whole chat history, you actually send the chat summary all the time. So you are reducing the amount of input tokens, but still you can have like all the details from entire chat. There are a few other techniques which are available, which actually first became a techniques, and then we saw that customers actually like can improve efficiency, reduce latency, increase accuracy. And those techniques available now as Bedrock features out of the box, which you can use. I don't have time today to cover all of them. It's just to mention it's prompt caching. For same prompts, you can leverage prompt caching capabilities, and you can reduce cost by up to 90% and increase latency because the prompts which taken from cache will be faster than from output from LLM. You can use also intelligent prompt routing when you use smaller LLMs to decide for each specific question or topic which larger LLM to use. So that's again how you can reduce total cost by up to 30% from our experience. And you can use also like Bedrock model distillation, where by using your data and larger model, more expensive model, you can distill the model and use the smaller model, like distilled smaller model, but still achieve the accuracy and the richness of result of a larger model, but at way lower cost. Now to summarize, I had just 20 minutes, so I tried to pack this session as much as I can. To summarize all the governance best practices for generative AIs. They are very similar to all your governance best practices for, traditional workloads. Control access to the models, control access to what your teams can actually do, right, with these models. For example, not everyone should have access to provision throughput, right, because it may be quite expensive. So make sure that people have you follow least privileged principle. You want to give flexibility for your teams to experiment, so have some dedicated playground accounts for that. But restrict production accounts to the models which kind of you approve to use as on organizational level. Have right tools for cost monitorings and set the budgets and define the boundary of your spend for generative AI workloads. Also, establish cost allocation and tracing. So make sure that you can allocate your token usage by application, by department, by billing, and by business unit. And you can actually allocate and tag Bedrock token usage by using inference profiles. Application inference profiles basically allow you to just tag them and set the model which you're going to use in that inference profile. And then once you use in your application, not the model directly, but through inference profile, you will see those tags propagated to cost and usage report, to cost explorer, to Kudos dashboard, everywhere. So you can allocate the cost pretty much the same way as with traditional applications as well. Of course, have cost anomaly detection in place and alerts, and make sure that people read those alerts and react on them. Think about this marketplace nuance that I mentioned, and if you use third-party models, make sure that your anomaly detection strategy covers this. And one of the most important parts is define your KPIs to measure return of investment of GenAI workloads. Actually, to maximize efficiency of generative AI workloads, you need to make sure that you know how to measure efficiency. And here you can apply different levels how you measure them. Track cost per business driver, like unit cost economy. Track cost per maybe useful response. Implement feedback loops in your generative AI applications. Make sure that you can actually track cost of useful response versus cost of not useful response. Track cost per token, what I showed we have in Kudos, for example. And then also measure different business impact of your generative AI workloads, like did we manage to reduce amount of support tickets or people engagement due to implementation of generative AI applications? Did we manage to increase sales from AI-generated recommendations, or did we manage to save some time per employee? So it's also very important to track and measure and to make sure that you can actually understand what the business impact your generative AI workloads bring, to make sure that you can actually, once you start optimizing, that you can measure impact of these optimizations to your business. That's all from my side. I really thanks everyone for joining today. So I don't know if we have time for questions, but really thank you, and I hope you learned something new today.